In this video, I'm going to use a set of data in fractions to make a line plot and use the operations of fractions to solve problems involving information presented on the line plots. Now, on the data we have was Kevin interviewed some local chefs. He asked how many cups of chocolate they use in a batch of chocolate candy bars. The number of cups used per chef is as follows: 1 3/4, 1 3/4, 178, 1 1/2, 1 3/4, 1 3/4, 158. Now, from this data presented, you will see that some of the fractions have been simplified. Okay, you will see that the denominators are different. So, but if you can plot, if you can make the line plot the way the data is presented, fine. But some of us get confused when the denominators of the fractions are different. So what you can do is change the fractions to make sure the denominators are all the same by looking for the equivalent fraction. And the way to do that is when we go down here, from the data we have, we will see that 1 3/4 and 1 1/2 are the ones that have different denominators. So we're going to change that to an 8. So when we multiply 1 3/4 by 2, we get 168. When we multiply 1 1/2 by 4, we get 148. So the data we're going to use will be 168, 168, 178, 148, 168, 168, 158. I like using the data with the same denominators. That way, if I have to solve any problems later, I don't start, I don't get all confused with it. But they are both the same data from what we see from the line plot. So when you plot the line plot, this is what you will get. This is the result of the line plots. Now, you've been plotting line plots in second grade. You know how to plot line plots. But what you have to do is count the number of points on your line plot. 1, 2, 3, 4, 5, 6, 7. The number of x's is 7. The data I have is 1, 2, 3, 4, 5, 6, 7. So everything is correct. Now back to your line plot. Now you can solve it with the equivalent fractions, or you use the original data. Now if we go back to this graph here, you will see the original data is in red. Now if I click on here to show us the equivalent fraction, you see 168 is 1 1/3, and 1 1/2 is 148. So whichever way it's easier for you, that's the way you plot it. Now we go to the second question is, what is the total number of cups used by all the chefs? Now the total number, you have to add all the data together. So there are two ways you can do that. You can leave the data the way it is, or you can use the equivalent fractions also to solve that. So I've solved it here. I'll leave this up for a little bit so you see how it's done. Collected the like denominators, added them up, and add everything up. I got 1 1/2 plus 3/2 plus 7 equals to 12. I'm not going to spend too much time on the fractions because we should know how to do that by now. Now the second method is to use the equivalent fractions. So I've done that. When you add the whole numbers, you have 7. The numerators we give was 40 divided by 8. That would be 5. So 7 plus 5 would also be 12 cups. On the third question is question 3 is, what is the difference between the greatest number of cups used per chef and the least number of cups? From our data, you will see that the greatest number is 178 and the least is 1 1/2. If you don't get it from the data, you don't understand it, then go back to your line plot. You will see 178 is the biggest amount or most amount used by a chef, and 148, which is the same as 1/2, is the least amount. So when you subtract 178 from 148, you get 3/4 cups. Thank you.